Yeah, Jim Rybicki, assistant professor in the physics and astronomy department, and the course I teach is Physics 100, Physical Science. The course title, Physical Science, isn't very descriptive of what the class is. So in the class, we're looking at learning the fundamental laws of physics and seeing how those apply to a broad range of topics. So we start out with learning about motion, velocity, acceleration, force, but then we apply those to a lot of other topics. So in this class we look at, for instance, electric circuits, we look at magnetism, music, theory of sound, optics, so that can get us into art as well. And so while the class is about fundamental physics, it's also about how things work, trying to apply it to other topics as well.
So you can really see that they do truly have two poles. So I have some generic refrigerator magnets. I don't have any business advertised on there. And I want to explain how the poles are set up here, because what we were looking at yesterday was we just had a plain old bar magnet like this with a north pole on one end and a south on the other side. But you might have seen another type of magnet, instead of it being a bar, where it's actually bent. And you get a horseshoe shape instead. So you take this same thing, you've got a north pole here and you've got a south pole here, and you bend it over and you get more of a shape like this horseshoe shape. And these still has two poles. I can look up, these want to repel. You're going to have to take my word for it until I pass around. These want to attract. I can't get this one to attract, this repels, so these two must be attracted. You can see that there are two different poles.
The class meets for 3 hours a week with 1 hour lectures, but then on top of that, there's also a 2-hour lab. And so the class is really divided up between those two experiences. So students learn from solving problems numerically, although I would say that it's a conceptual-based course. We don't expect you to come in knowing a lot of math for this course. But on top of solving problems numerically, there's a lot of demos that we do in class. We discuss how those apply to the laws that we're learning. And then you go to lab and you do experiments that sometimes introduce these concepts and sometimes reinforce what we've done in lecture. On top of that, we'll look at simulations and sometimes videos where we try to, something we like to do, for instance, is bad physics theater. So we'll show some movie and say, okay, what's wrong with the physics in this clip? And that would just be another way that we can discuss that. What I'd like students to take away from this course, I'd like them to take away that from starting with a very small set of laws, that we can build up a lot of information. And so at the beginning of the class, we learn an equation that says force equals mass times acceleration. And we can take that simple equation and apply it to a broad range of things to understand it. So that applies when we're talking about, say, a ball being thrown through the air, or how a guitar string works. And so I want them to get from this class how things work, but also this appreciation that we develop these laws, and from that we can use those to describe the world around us.